Hi everyone, my name is Harry and my group member is Ricky, and we are giving the presentation today. I'll begin by introducing our project and motivation behind this. Cardiovascular disease remains one of the most leading causes of death globally. However, early detection can dramatically improve patient outcomes and reduce long-term healthcare costs. That is why our clients, including hospitals, clinics, and public health researchers, are so interested in predictive models for health disease. And in this project, we collaborated with them in mind using the Cleveland heart disease dataset, which includes 13 clinical features such as age, sex, resting blood pressure, and so on. Our goal was to build models that could accurately predict heart disease outcomes using this dataset and recommend practical solutions for deployment in real-time healthcare setting. So we created those two classification problems, and I'll go with the very first one, the binary classification model. To begin with, we clean the data set we are using by removing rows with missing values, which left us with 303 complete records. All of the features or standardized to have a zero mean and univariance to ensure fair treatment across models. This will help us to have a better model like CNA and PCA. For this binary classification model, we examine the variable distribution here. For instance, the age and resting blood pressure have a fairly normally distributed, and cholesterol is right skewed, gender is imbalanced, and chest pit height turn out to be highly predictive. Say there's certain types were clearly more common in patients with heart disease, and all of those observations guided our modeling choices, especially for selecting the appropriate metrics and transformation models. Here is the form for supervised learning model we used in our project. So they're Killian, decision tree, random forest, and neural network. Each of them have the strength and weakness, and we choose to use F1 score as our performance metrics because it solved the problem of class imbalance. Uh, we use the hyperparameter tuning by using the grid search with five-fold cross validation. And those are the value we choose to do this research. We also apply PCA to our model, so we actually apply the research before and after using this PCA. The reason we're using this PCA because we try to solve the problem of collinearity. Also, we want to avoid overfitting our model. We are then we just reduce from 13 features to 6 features by applying this PCA. And here's a table that concludes like our model like before and after PCA. Here is some key metrics we need to pay more attention. In the model of Killing and Random Forest, the F1 score drops a little bit, while in decision tree model, the F1 score increases a little bit. And also the neural network model stay kind of consistent. This mixed impact reflects how PCA benefits some of the models, especially those prone to overfitting but may harm others that rely on raw feature structure. So overly, I think this PCA is kind of meaningful to our model because it solves a lot of problem while the performance of the models are kind of balanced. In this case, uh we we, we choose to proceed with the post PCA hyperparameter, and those are the four hyperparameter we choose after applying PCA as well as the grid search method. Finally, we use the hyperparameter to train each of the model and use the validation set to evaluate our performance of each model. And here is like the table of all the precision recall F1 score. And We evaluated this score to choose one of the best models, and here's our conclusion. The, dis the decision tree achieved the highest F1 score, uh, and the runtime is pretty quick. So we choose the decision tree as our top performer. Uh, and neural network also did pretty well, but took over 2 seconds to train, so it took a long time. And Ken Random Forest lagged slightly behind. So the winner is decision tree on model. So given the clinical application, we recommend the decision tree model with post PCA for deployment due to its interpretability and accuracy. So in the future, we're combining PCA with feature selection methods or some like more deeper architecture to have like a better improvement. Then my roommate Ricky will talk about his classification problem.
The score started with the classification problem 2, predicting the ST segment depression during exercise, which can help the doctor and hospital to detect who is a high-risk patient. And for the data set, we use the same data set but define a new binary target, the opaque target, which means if the uh, ST segment depression is over 2 or 2.0, this means 1 and 0 is otherwise. This gives us a clear distinction between high risk and the lower risk patients based on exercise ECG result. And we also do the same processing with the data set and choose the same model. First, we can see that without PCA part, you can see that random forest and neural network can reach the higher higher F1 score, and decision tree and KN is lower than them. And with the PCA, you can see that the KN and decision tree didn't did a better job by use the PCA, and also they increased the training time. But you can see that the random forest and the neural network significantly increase their performance and reduce their training time. So, which means the random forest and neural networks will be more fitable for the problem 2 to do the prediction job. And comparing with the random forest and neural networks, uh, we recommend the random forest on PCA reduced because of the random forest can reach the highest F1 score, but uh, it do lower training time than the neural networks. We can save a lot of time by using the random forest. And so PCA performance really well in this task. It can significantly help them to improve the efficiency of the complex models and reducing their training times. So it means that PCA effectively reduced the dimension reductance, which is especially beneficial for the resources sensitive modules. So in this task, we will uh, recommend the random forest instead of the neural networks. Uh, comparing with, comparing with these two classification problems, you can see that maybe because the problem ones has more significant features, so simple modules like the decision tree will do the better jobs in the problem 1 and get a higher F1 scores. And in a more complex problem 2, we need more complex the modules like random forest and with the PCA, and but it will also get a lower best F1 score. So finally, in this project, we explored two meaningful classification problems. Use this data size, and we will recommend the decision tree to help the doctor to detect the heart disease, and use the random forest to help the doctors to predicting who is the high risk patients. And this is all of our presentations. And thank you for your listening.